So hello everyone. So this is the question of transistor circuit, and here it is given that this transistor circuit should always be in the active region. So it is given that this is should be in the active region, and these values is given VC set 0.2 volt and VB 0.7 volt, and this is actually redundant value because the transistor is an active region, so there is no meaning of the saturation parameter. So we have to calculate the maximum value of RC in ohms which can be used. So this RC value, resistor value, we have to calculate. So we have to apply the condition of the active region. So the active region, for active region, VCE should be greater than equal to 0.7 volt, and the minimum value of VCE is equals to 0.7 volt, right? So for V, this is the VC. So for using this condition, we have to apply a KVL here, -5 plus, now this current is IC, and this is the IB current, and this is the ammeter current. So we have to apply a KVL here, but IC is unknown. So for getting the value of IC, we have to apply a KVL in this loop also, because in active region IC is equals to beta IB, and here it is values given as 100, so 100 IB IC. So first KVL is apply in this loop, and so in this loop, and second KVL in this loop, right? So this is the first KVL, this is the second KVL. So let's apply the KVL. So first KVL, -5, then plus IC RC and plus VC is equals to 0. So everything is unknown here. So VCE, when we have this condition that VCE, which is equals to, here in terms of this, there is 5 minus ICRC. This should be greater than equal to 0.7 volt, and which is for this ICRC will be less than equals to 4.3 volt, right? So this is the first condition we got. Now in the second KVL, we will apply like this, that -5 plus IBRB plus 0.7 -5 plus IB into RB plus of 0.7 is equal to 0, and RB is given as 2 kilo. So this is minus 4.7, so this is the 2 kilo, so it is 2 IB and is equals to 4.3. So IB is equals to 4.3 divided by 2, that is 2.15, and this will be in the milliampere. Now from this, the IC, that is 100 IB, which is equals to 215 milliampere, right? Now so simply substituting this value here, so 215, now this is in milliampere, so RC will be in kilo, and it is less than equals to 4.3. So this value is 4.3 divided by 215, that is 0.02, and it is in kilo ohm, so we have to give the answer in the ohm. So RC should be less than equals to 20 ohm, which means the maximum value of RC is 20 ohm only, right? So this is the answer. Now if we want to solve this question in a single KVL, so we can go with this also. From here, यहाँ से start होते हुए, and in this path, this is the IC, then here it is the VCB, so taking along it is VCB in the KVL. So in this path, along this path, यहाँ पर and it will end on this -5, right? So in this KVL, so this is the KVL, so -5, then plus ICRC, this ICRC plus of this is the VCB. Now we are going in this direction, right? But the current is coming in this direction, so we have to take care of this direction of the current. So it will be minus 2 IB and then plus 5. So it will be minus 2 IB and then plus 5 is equals to 0. So this is simply cancel out, and यहाँ पर VCB should be equals to 2IB and minus ICRC, and the condition of VCB is VCB should be greater than equal to 0 volt for the active region. So we will simply apply here should be greater than equal to 0 volt. So now 2IB should be greater than equal to IC into RC, and here RC will be less than equals to 2IB upon IC, and now we can simply substitute RC or IC to be 100 IB, and there is no need to calculate this individual IB and IC here. So we have got the answer in the ratio only. So this is the RC should be less than equals to, so this IB is IB cancel, and this 2 was in kilo, but because this is the 2 kilo resistor, it is RB, so this is the 0.02 kilo, and यहाँ से RC is less than equals to 20 ohm. So the maximum value of RC is equals to 20 ohm. So this is how we can solve, because and this V, so here there is no need of calculation of this V, IB and IC and all. We have got the answer in the ratio form, and so this is a very good KVL, and actually this condition is more important than this VC, because this is derived from here only. So this is the more important condition, and here we can see like this, because this is the NPN transistor. So this is the collector, base and emitter. This is the N, P and N, and this is the VCB, which should be in this polarity, right, for the collector junction to be reverse bias. So this should be the polarity of VCB, which we have used here. This is the polarity of VCB, which should be for the collector junction to be reverse bias for the active region. So this was the question. So okay, thank you.